So again, we're just going to call this interval notation, okay? So I'm not going to give it any type of section number. It is from chapter 4, but it doesn't have its own little section. It's kind of just like an added extra.
Do we have to take notes on this?
You always should, because I always check your notes.
When's our next shipping be?
It's always after your chapter test, so yeah. So maybe you've seen stuff like this. So let's just assume that A and B are numbers, okay? Or maybe you've seen stuff like this. I mean, you should have at some point seen things like this. So these are intervals, okay? Using inequalities. Now, for the first one, the very top one, that basically says that x is between A and B, but cannot be equal to A and cannot be equal to B. Okay? So that's what the top one says. The second one says that x belongs between A and B, but it could be A and it could be B. The third one says that x lies between A and B. It could be A, but it can't be B. All right, because it doesn't say or equal to. And the very last one says that x is found between A and B. It can't be A, but it could be B. Right? So these are different ways that you've seen kind of these inequalities that maybe we put down whenever we solve for different things. But I'm not sure why it's doing all that weird stuff. But what they want you to do is to write this out in set notation, okay? So, for set notation, we use parentheses for less than symbols, okay? We use brackets for less than or equal to's, okay? Now, depending on where the less than or equal to is, it might be the left side bracket or the right side bracket. It just kind of depends. So, for example, for the very top red one, right? The one I have A less than X less than B, I would write it like this. A to B, and it's going to look like that. Now, a lot of people get confused with, like, is this a point or is this an interval? And how would you know? Well, it's all based on context. If the problem is saying we're going to graph a point 2, 3, then you know it's not an interval because they literally said it's a point, right? But if they tell you like, okay, A to B, this is the interval where the function exists, then you know it's not a point because they mentioned interval, okay? So you have to pay attention to the instructions. That kind of tells you what to do. Now, for the second red one, it's going to look like this, with brackets on the left side and right side, not parentheses. Okay, because they have a less than or equal to on the left side, they have a less than or equal to on the right side, so both the left and right get the bracket. Now, for the third red one, you're going to get a bracket to start and a parenthesis to end. Because notice on the left side of that red mark, the third inequality there, it says A less than or equal to X, so that means we put a bracket on it. And then it says less than B, so that's why you put a parenthesis next to it. Okay, and then the last one, notice A is less than, right? So that's going to be a parenthesis. And then it says less than or equal to B, so that means you're going to put a bracket on it. Now, there are only two numbers that never can be bracketed. Okay, so let me put that right here. There are two numbers that can never have that can never have a bracket. Okay, so that's going to be negative infinity and positive infinity. Anytime you mention those two numbers, you must always keep it in a parenthesis. So maybe it's going to look like this, like negative infinity to 2, or maybe a negative infinity to 4. Or you could have like 6 to positive infinity. Okay, so there's going to be, I almost bracketed that, sorry. Should be a parenthesis. Or maybe a -1 with the bracket, but to positive infinity. Sometimes you get negative infinity to positive infinity. So it's the whole real set of real numbers. But notice how the infinities never get brackets, they only get parentheses because you can't include infinity in your answer. Since infinity is a number that's so large we don't know its value, then you just kind of say it's infinite, okay? But you can't capture it, so you put a parenthesis around it, okay? So these are some of the things you guys need to be aware of. Now, if you look at the information that you've been given, I'm just kind of curious, how many of you guys, if you guys wouldn't mind, just kind of show of hands really quick, have done work with interval notation before? How many of you guys have seen this? So none of you, so I want to, about 3 or 4 of you guys. So yeah, a lot of teachers, they don't teach it because they don't feel they have to. I usually, whenever I would teach this stuff in Math 1 and stuff, I try to teach it because I know it's going to be coming up later. But a lot of teachers just kind of pass by it because they figure, oh, you'll learn it in trig. But it's kind of nice to learn it now because you'll see it in tests. You'll see it in state tests and things like that. So again, this is called interval notation. Now, the way we do this is that, well, there's a couple ways that they might make us do it. First off, let me show you here. So example number 1. They might tell you that they want you to write the following in interval notations. Let me put this down. Write in interval notation and graph. So write it in interval notation and graph. And we'll do 2 little problems here. X less than 10, and we'll do x greater than or equal to 4. So x less than 10 basically means that x can be any number less than 10. Now, notice how it's not written inside, like, let me go back up here. It's not within like a bunch of little numbers, right? It's just one side. It's just like if they got rid of everything except for like this part, right? They're just saying like x is less than that or whatever. So what's going to happen here when they say x less than 10, you have to understand that x can be any number that's less than 10. So in other words, 10 is the highest number it can be. Now notice it says less than, so I'm going to put a parenthesis. Well, how low can I go? Well, you can go as low as you want. So we're going to put negative infinity. And that's my interval notation for part A. Because x can be any number less than 10. So 10 is the highest and any number below it. So we go to negative infinity, right? Saying like as small as you want. When they ask you to graph it, okay, I always tell people to do this. Now, right here, they give you a 0. So I'll do the same thing here. I'll put a 0 right there, okay? Me personally, I prefer it on the bottom of the graph, but they put it on top here. So they say less than 10. I'm just going to mark 10 right here, okay? And then less than means that your circle should be open, right? Because it doesn't say less than or equal to. So it just says less than 10. And then it's going to go to the left. So that's your graph for that function. Okay, you're just going to be going towards the left-hand side. Again, the reason why the circle is open is because you can see that there's a parenthesis around 10, which means it's not included in your answer, right? A bracket means it's included, but a parenthesis means it's not included. Now, for part B, same idea. They say x is greater than or equal to 4. So that means x can be as low as 4 and higher, right? So I'm going to write this. 4 to positive infinity. Okay? I include the 4 using a bracket because it says x can be greater than or equal to 4. So 4 is included. Okay? And then any number bigger than that. So any number bigger than 4, well, 5, 6, 7, 8, 9, 10, a million, a billion, a trillion, whatever. So we just say towards positive infinity. And remember, the infinities never get brackets. They always get parentheses. So what I'm going to do now is I'm going to graph it. kind of the same way that they're doing, right? They put a 0 there, so I'm just going to put a 4 right here. Now, since it is a greater than or equal to, I get to put a solid dot, okay? And then I'm going to go that way, because that's where all the numbers bigger than 4 are. Okay? Now, being able to do that, that explains numbers 1 through 5 on your homework. Okay? Those are examples that help you do numbers 1 through 5. Now, let's look at 6 through 10. Things like numbers 6 through 10 in a different example here. So example number 2, they want us to write each interval as an inequality. So write, let me start again here. Write each interval as an inequality. So again, I'll just give you two parts here, an A and a B. So we'll do like let's do a negative infinity to 4. And we'll do a 6 to positive infinity. Now, notice negative infinity to 4. That means the number can be as small as you want it to be, but it can't be any bigger than 4. And it actually can't even be 4 either. You're going to reach 4, but you can't have it equal to 4. So, that means that x has to be less than 4. Because it can be less than 4, right? It can be 3, 2, 1, 0, and any negative number. But it can't be bigger than 4, and it can't be 4. So I'm going to put x less than 4. That's my inequality. Now, for 6, including 6, right? The bracket, it includes 6, and it goes to positive infinity. So in other words, from 6 and bigger. So I'm going to say x is going to be 6 or bigger than 6, right? So greater than or equal to 6. So it can be 7, 8, 9, 10, etc. Millions, billions, trillions, all that stuff. So that's the way it's going to look like when you write your inequality. Now, they're going to want you to just write your answers for numbers 6 through 10 on the side, okay? So no big deal for that one. Now, hopefully you guys don't see it as a big deal. Now, number 11. Okay, let me give you an example of something like number 11. Not example 11, I'm sorry. Number 3. By the way, right now that I remembered about this, for those of you guys that did not take the quiz this Friday, okay, tomorrow during lunch, you got to come in and take the quiz, okay? There were 8 people missing in this class and 8 in the other class. That's actually a perfect number because that's 2 groups. Okay, bless you. So I need you guys to come in and take it. I can't have you do it like during class because you guys are going to be discussing and I'm going to be teaching and it's not good. So it has to be during lunch tomorrow. If you show up and 3 people show up and that's all that shows up, then they get tested. Okay? But make sure you guys show up tomorrow. All right, that's the time I'm going to give you for the makeup. Anyway, for number 3, they want us to write interval notation. So write the interval notation for the graph. And, we're just going to kind of draw something here. They like putting zeros on stuff, so I'm just going to go like from 2 to -3, and we'll make it look like this. Notice how it's closed at -3 but open at 2. Okay? It's closed at -3 and open at 2. I'm going to put a little sign A there so we can do another one after this. So your answer for this one, you should have a bracket with -3 because -3 is included. The dot is solid. And at 2, you're going to keep an open parenthesis because it cannot include the 2. It can go all the way as close as possible to 2, but it can't be equal to 2. Now, just to give you one more, if you had, let's say, something like this with the 3 there, and you have a graph that looks like this, well, notice it can be as big as 3, but it has to be as small as possible, right? So we're going to say, all right, small as possible would be a negative infinity to a positive 3, non-inclusive, because the circle is empty, so you don't include it. So that's how that would look, okay? Number 11, that type of problem is done that way. And actually, 1 through 6 on the back are just like number 11 on the front, okay? So if I can, I'm just going to do 3 problems for you guys, okay? I mean, it's not a lot, but it's better than nothing. And they're not that hard to do. So let's go up here really quick. 1 through 5, which one do you guys want to see? Give me a number. Number 2. Okay, so number 2 says put it in interval notation and draw the graph. So number 2 says x is less than 6. So 6 is about here. Less than, that means open circle going down. And if they want me to write it as an interval, well, notice it goes as small as possible, and the biggest it can be is get really close to 6. So it's going to look like this, negative infinity to 6. All right, now let's look at the next set right here, 6 through 10. Which one do you guys want?
9.
Number 9. So it says write each interval as an inequality. Notice how the negative 10 is included, but the infinity is not, right? So it's going to look like this. Now, by the way, some people write the following, and let me just show this to you. This is not wrong, okay? That's not wrong. But most people say, well, just erase the infinity part. So if you go like this, you got it right. Okay? Or if you want to write it the other way, so it just faces this way, that'll be fine as well. Okay? But basically every number greater than or equal to negative 10. Right? So that's what we wrote. Okay? So that's that. What about the second page, 1 through 6? Which one? Number 4. So number 4 in interval notation is going to look like this. Notice there's a negative 3 and a 4. The negative 3 is not included. The 4 is. So pretty easy, right? These problems? Yeah. These problems are pretty easy. They don't take very long. Anything like number 5, if something looks like number 5, is there another one? No, there's only one. But, oh, actually, there it is. 5 and 6. Those are ones that go towards infinity. So like for number 5, you want to say every number bigger than 5. And that's all you want to say, right? For 6, you're thinking numbers smaller than 0, right? So anytime the arrowheads go on forever, that means that those go towards infinity. So I'm going to go ahead and stop. We got like 6 minutes, I think. Huh? Number 9, yeah.
Wait, you keep the negative?
Yeah, the negative 10 has to be included.
You wouldn't change it to a positive?
No, because what this says is that if I were to graph it, it would look like this. So here's the graph for it. So it's any number from negative 10 on. So that's why we say x greater than or equal to negative 10.